All right, folks, now that you know how to calculate a logarithm using the change of base formula, you've been introduced to the natural log. You have learned basically how to cancel exponential bases. So now you have all the skills that you need to be able to solve exponential equations. Now, when I say solve exponential equations, I mean the same thing as solving basic equations. Only instead of being polynomial, they are exponential. Your variable is up in the exponent. So you're accustomed to solving something like, 7x plus 5 equals 19, right? In this case, you just subtract 5 from both sides, and we get 7x equals 14, divide by 7 on both sides, and we get x equals, divide by 7 on both sides, and x is equal to 2, right? So you know how to do this. You know how to solve basic polynomial equations because you have learned that, many of the techniques that are necessary for canceling polynomial terms in polynomial equations. But now we're moving on to exponential equations. And this requires the ability to cancel an exponential base, which you learned how to do in the last video when we learned about how logarithms are used for canceling exponential bases. Okay, so what I'm going to do is I'm going to walk you through this exponential equation, and then we're going to do a few more examples and build up your skill in solving exponential equations. In order to do this, you are going to need a scientific calculator and probably some paper and a pencil. So you're going to want to do this along with me. Okay. All right. Here's the deal. We can never cancel an exponential base with an exponent if there are other things with it. Okay. So for example, do you see this 400 up here? This says 400 times 1.137 to the power of 4x. This 1.137 is being raised to the 4x power, but this 400 over here is not being raised to the 4x power. Okay? So we cannot cancel this exponential base until we get rid of this 400. What is this 400 doing to this exponential base? It's multiplying. So how do we cancel multiplication? We cancel multiplication by dividing. So the first thing we're going to do here is we're going to divide by 400 on both sides. If I divide by 400 on this side, I have to divide by 400 on this side. So over here it's going to cancel the 400, and all I have left is 1.137 to the power of 4x. Now that I don't have the 400 in front of it, I don't need the parentheses anymore. Now you can leave the parentheses if you want, but we don't really need them anymore. Now this is going to be equal to, well, what's 1100 over 400? Well, if you cancel if you divide out the zeros here, all you have left is 11 over 4. So this is equal to 11 over 4. Now if you did it in your calculator, you would get 2.75. And that's okay too. If you wanted to write it as 2.75, that's fine. So you could have 1.137 to the 4x power equals 2.75. I'm going to work with a fraction though. I'm going to leave it as a fraction because sometimes it won't become a terminating decimal. It won't be something really nice and easy to work with. It'll be a crazy 7-digit long decimal. And I want it to be precise. So I'm going to leave it as a fraction. Now, in the last video, we learned that the way we cancel this exponential base to get this x by itself, well, we got to get the 4x by itself first. The way we're going to cancel this exponential base is by doing log base 1.137 of this side and log base 1.137 of the other side. We have to do the same logarithm to both sides because it's an algebraic equation. And the golden rule of algebra is you have to do precisely the same thing to both sides of the equation when you are doing anything at all. And so log base 1.137 will cancel the exponential base of 1.137, and all we have left is this 4x. So we're going to bring that down. 4x equals Over here we have log base 1.137 of 11 over 4. Or maybe you did it another way and you wound up with 4x equals log base 1.137 of 2.75. And that's fine too. It'll be the same thing. Now, at this point, you can either plug this in your calculator and get a number, or you can divide by 4 first. I'm going to divide by 4 first. I like to do all my figuring, all my algebraic work first, then punch it in a calculator. So we'll divide by 4 here to cancel the 4. That means we have to divide by 4 here. And so now x is equal to log base 1.137 of 11 over 4 divided by 4. And this is a number. This is a final answer, but we want to key it into a calculator and try and find out what is that number, because it's not very useful to us like this. But if we were asked, like for example, if you were in like an advanced calculus class or something like that, and you were asked to solve this, they might expect you to key it in just like this, because this is a precise number. It's not approximated. Over here, we could do the same thing, divide by 4 on both sides, and we would have x is equal to log base 1.137 of 2.75 over 4. Now, to find out what this is, I need to enter this part. See the numerator here? I'm going to need to use the change of base formula on that. Remember, the change of base formula is log base a of b is equal to log, the common logarithm of b, divided by the common logarithm, log of a. And so now here, I'm going to do log of 11 over 4. So that's why I'll key in my calculator, log 11 divided by 4, close parenthesis. So I'm doing log 11 over 4 divided by log 1.137. 1.137 divided by log 1.137. Press enter, and I get 7.878928131. But I'm not done yet. That's this number. I have to divide by 4. Then I'll hit divided by 4, and x is now equal to 1.9697. And that is my final answer. And if I did the same thing over here, it would be log 2.75, close parenthesis, divided by log 1.137, enter, and then divide by 4, and it's the same thing, 1.9697. Okay? So that's an exponential equation. Let's do another one. All right, here's an exponential equation. Feel brave enough, why don't you pause the video and see if you can solve it yourself. All right, let's see how you did. Got my scientific calculator here ready to go. Remember, I can't do anything with this exponent until after I've gotten rid of this 43, so I'm going to divide by 43 on both sides. Divide by 43. Now, dividing 19 by 43 is going to be a little bit of a mess. Yeah, it gives me like 0.4418604665. That's a crazy decimal. I may as well just leave it as 19 over 43. So now I have 0.9962 to the power of 12x is equal to 19 over 43. Well, I want to get rid of this exponential base. So I'm going to do log base 0.9962 on the left side. I'm also going to put parentheses around this, and I'm going to do log base 0.9962 on the right side. Now on the left side, it's going to cancel my exponential base, and all I have left is 12x. So I'm going to bring down 12x is equal to log base 0.9962 of 19 over 43. Okay? Now to solve for x, I'm going to divide by 12 on both sides. And x is equal to log base 0.9962 of 19 over 43 divided by 12. Well, how am I going to do this logarithm? How do I do log base 0.9962 of 19 over 43? Well, I can use the change of base formula. right? I need to do log, the common logarithm of 19 over 43 divided by the common logarithm of 0.9962. So in my calculator, I'm going to type in log, I'm going to hit the log button, then 19 divided by 43, close parenthesis, divided by log 0.9962, close parenthesis. Now I'm going to press enter, and I get 214.5285, right? But look, that's just this number. I still have to divide by 12. So I got to divide by 12, and I get x is equal to 17.8774. And that is my solution to this my solution for x to this exponential equation. Let's try maybe one or two more, okay? All right, we've got this exponential equation. All right, now it has an e in it. And this is actually going to make it a little bit easier. Do you remember in our last video we said to cancel an e, we use the natural log. We use ln, correct? So that's going to make this a little bit easier. Now, I can't cancel this e until I've gotten rid of the multiplying number in front of it. So the first thing I need to do is divide by 70 on both sides. It's going to cancel the 70 over here. It's going to leave me with e to the power of 0.056x equals, here, 500 over 70, the zeros can cancel, and I have 50 over 7. So 50 over 7. Now, if I did that as a decimal, it would be 7.142857143. That's sort of messy. I don't want to have to deal with such a nasty decimal, so I'm going to leave it as 50 over 7. Now, in order to cancel this e, I would use log base e, right? I could put log base e here and log base e here. Because remember, e is not a variable. E is a number. It's just easier to write as the letter e than as the number itself. It's a crazy, irrational number. Kind of like a lot of people that I know, crazy, irrational people. Man. All right, so e is a crazy, irrational number, though, but at least it can be simplified down to the letter e. That's helpful. All right, so to cancel this, we got to use log base e, but log base e is the same thing as ln, the natural log. So if I do the natural log of this side, I also have to do the natural log of this side. Remember, there's a button on your calculator that literally says ln. That's the natural log. On this side, it's going to cancel the e and leave me with 0.056x equals the natural log of 50 over 7. Okay? We're almost done here. We want the x to be by itself, so we want to divide by 0.056, cancel, divide by 0.056, and we have x is equal to the natural log of 50 over 7 divided by 0.056. Well, we can do the natural log of 50 over 7 in our calculator. We just hit the ln button. Look at this. See, watch this. I just hit the ln button, ln, and I get ln. 50 divided by 7, close the parenthesis. Press enter. I get a crazy number. Then divided by, right, divided by 0.056. Divided by 0.056. Press enter, and I get 35.1092. So x is equal to 35.1092. And that is our solution to this exponential equation. See, exponential equations, they're a piece of cake. Once you know how to cancel the exponential base, this stuff is really easy. And once you know how to enter the logarithms in the calculator, really is a piece of cake. Let's do one more problem. All right, here's one more example. We've got an exponential equation. It's got a base of e, so you know you're going to use the natural log. Why don't you pause it and try this on your own? All right, let's work this out, see how you did. I can't cancel this exponential base until that 200 is gone, so I'm going to divide by 200 on both sides. Cancel, divide by 200. I don't think I can reduce this at all, this 67 over 200. And even if I could reduce it, it doesn't matter if I reduce it or not. It'll still turn out okay. So now I have e to the negative 0.13 x power is equal to 67 over 200. All right, so now we can cancel the exponential base e because there's nothing else over here. Okay, so to cancel an e, we would need a log base e, but remember, natural log, ln, is the same thing as log base e. So we're just going to put an ln here, and if I do the natural log of this side, I have to do the natural log of this side because it's algebra. So this natural log of e, that's going to cancel the base of e and leave us with negative 0.13x is equal to the natural log of 67 over 200. Almost done. Now, to get x by itself, we're going to divide by negative 0.13. That's going to cancel here. Divide by negative 0.13. And now x is going to be equal to the natural log of 67 over 200 divided by negative 0.13. So we'll do that in the calculator here. We'll do ln, natural log, okay, of 67 divided by 200, close parenthesis. We could actually do it all in one calculation. Now that we have that, we can just hit divided by negative 0.13, negative 0.13. There we go. Press enter, and this should give us our answer. Our answer is 8.4125. So x is equal to 8.4125. And we have solved for x in this exponential equation. So I'm going to give you about probably a dozen of these exponential equations so that you can practice. You have to be very good at solving exponential equations so that you can then solve. We're going to go into word problems where you're trying to solve for the rate or the time in an exponential growth or an exponential decay problem. And normally the rate and the time, they go right here in the exponent. So you have to be able to solve those things, okay? All right, well, that's it for now. Watch the next video. In the next couple videos, that's where we do some actual exponential growth and decay problems where you solve for the rate or for the time, okay? All right, see you later.